Hello guys, I'm back again with you. My name is Joseph Ejike Oji. I hope you guys enjoyed your Independence holiday because I enjoyed mine. So I'm back again with a new lecture for you. The topic of the day is probability distributions. In the past week, 2 weeks, we've been working on the concept of probability. Now, let us discuss what we called the probability distributions. Let's start. Now, before I explain the meaning of probability distributions, let me give you some background information that will be very important for you because it will help you to understand the concept of probability distributions. Now let's look at the basics here. First of all, look at the variable. Any variable, anything that is being measured, any quantity that is being measured is called a variable. And we use X to represent it whenever we are doing a problem that involves probability distribution. We use X to represent the variable. Now, when these variables are measured, or let me put it this way: so long as it is the quantity we are measuring or that we are interested in, we use X to represent it. We call it the X variable. Okay, a good example: some things like age, religion, grades in exam. All these things are variables. Okay. Now, when these variables are random, that means when they occur by chance, we call it a random variable. Good example is if I toss a dice. I'm sure I have shown you the picture of a dice before, but let me show you one here, right here. I see the dice. So you have 1, 2, 4. On the other side, you have 3, 5, and 6. So if you toss a dice, the outcome can be 1, 2, 3, 4, 5, and those outcomes are random. Okay. Now, how about if you're standing on or sitting in a bus stop? The time of arrival of the bus, the particular bus you are waiting for, that is random. You can't determine it. The bus company might say, okay, this bus will arrive at 8 o'clock, but sometimes they arrive 8:15 or even earlier than that, 7:45. So sometimes it can be random. How about number of students, number of siblings a student might have? Any student in your class can have any number of brothers and sisters. You have no control over that. So a student that they put in your class, number of siblings that student will have is also random because you don't know, you cannot determine it by yourself. Okay, so we call them random variables. Now, there's one we call discrete random variable. These are the ones that we can count. Those variables that we can count, things like number of people jogging, number of people that are jogging in a park, or number of eggs that a hen lays. You can say 1 egg, 2 eggs, 3 eggs, but you can never say 1.5 egg or 2.5 eggs. You can't say that. The same thing with joggers. Number of people jogging, you can't say that 1.5 people are jogging. No, okay, but you can say that 1 person is jogging, 2 people are jogging, 10 people are jogging. See, you can count them. How about the number of telephone calls that you receive? You might receive 2 calls today, or 5 calls, or no call at all, but you can never receive 1.5 calls. Things like that. So we call them discrete because we can count them. Those that we cannot count, that is those that we are measured, we call the continuous random variables. Good example: height. You can measure height, 1 feet, 2 feet, 3 feet. Temperature. voltage, and so on and so forth. Okay. Now, with this background information, now I can now explain to you what a probability distribution means. That way you understand it better, because you already know what the background, you have been given the background information. I wrote here that a probability distribution consists of all the values that a random variable can have together with their corresponding probabilities. All the values a random variable can have and the corresponding probabilities, we call it the probability distribution. Okay? So now look at the types that we have. We have the discrete type, which includes the binomial distribution, Poisson, and geometric. There are many of them, but I just put 3 here because there are many. Now for the continuous, we have only 2, but there are others, but I put 2 here: uniform distribution and the normal distribution. Okay. Now let us do some examples on the concept of probability distributions. Let's try this. Construct a probability distribution for rolling a dice. Construct a probability distribution for rolling a single dice. So for a single dice, the sample space is 1 to 6. I've already shown you a dice here. You can see right there, 1, 2, 4. On the other side, you have 3, 5, 6. Okay. So for each outcome, it has 6 possibilities. So each outcome has 1 out of 6 chances of occurring. Remember, I told you that we use x to represent the outcome or the variable of interest. So for probability of x equals 1, meaning if 1 showing up when we throw that dice will be 1 out of the 6 chances. And for 2, it still means 1 out of the 6 chances, and so on and so forth. So when you put them together, we'll have the probability distribution right here. Remember the definition: the outcome that a random variable can take and the corresponding probabilities of those outcomes. The outcomes and their corresponding probabilities is what make up the this distribution that we called probability distributions. Okay? So we have answered that question. I'm sure you're having fun by now. Very easy, right? I told you I'm going to make it easy for you. Now, let's try another example, a more challenging one. It says here, this example is based on how to graph this type of distribution that we call probability distribution. How to graph it. It says here, represent graphically the probability of distribution for the sample space for tossing 3 coins. So the probability distribution for tossing 3 coins, draw the graph of it. That's what it's saying. So remembering that we use x to represent the number of heads, we can have I'm going to use a tree diagram to show you all the outcomes right here. So the first coin can have head and tail. Second coin, so from this particular head, we have head, tail, head, tail. The third coin, from this line, we have head, tail. So from the end of each of them, you have head and tail, head and tail, head and tail. Why? Because a coin have 2 outcomes: head showing up or tail showing up. So like I said, the first outcome can be head and tail. Second coin, say, from the tip here, you have head and tail. From the tip of this, you have head and tail. And the third coin, from the tip of all these tips, you have head, tail, head, tail, head, tail, head, tail. So this is the way to put it, so that we can have all the outcomes we need. So you are tossing 3, you toss the 3 coins. Head might show up on the first coin. Head show up in the second coin, and head on the third coin. That'll give us head, head, head. See? Or head might show up on the first coin, head on the second coin, head, tail on the third coin. Head, tail. Or head on the first coin, head on the second coin, head on the third coin. That gives us head, tail, head. So that's the way you follow it all the way down. Now, when I do this, my students will ask me, why do I choose head? Well, you can choose tail. It doesn't matter. It will give you the same results. So that means you go from here. So you can see that both ways will give you the same result. So I just decided to choose tail as because and use it at my X for finding the probability distribution for this example. So I have it right here. 0 head. No, that means no head showing up. You can see right here. There's only one possibility for no head showing up. Head, head, head. So that means we have 1 out of 8 chances. Why 8? Because if you count this, 1, 2, 3, 4, 5, 6, 7, 8. So 8 possibilities. So for 2 head, no head, for 1 head only, you have it right here. This place has only 1 head. This one has only 1 head. Sorry, this one has more than 1. This is one that has only 1 head right here. This one has 1 head. And this one also has 1 head. You can see right there. So there are 3 of them that have 1 head. So you're gonna have 3 out of 8 chances, and I have it here as well. Then for 2 heads, okay, we have this one have 2 heads. This have 2 heads. This also have 2 heads. So it's 3 of them again, 3 out of 8, and also and so on and so forth. You get all this, then you can now get the graph. The first one, just look at how I drew it. 0 head, 1 head, 2 heads, 3 heads. For 0 heads, we have 1 out of 8. See, I have it right here. 1 over 8. See, I drew the line from 0 to this place. First of all, I drew all the line, then I joined them to get this histogram. Now for 1 head, we have it right here as 3 over 8. So you can see 3 over 8 right there. Sorry, right there. So I draw the line from here, 3 over 8. And for 2 heads, 3 out of 8. Okay. So from here, I draw the line to this 3. See? So from here, as you can see the right. Now for the last one, which is the 1 head, 1 out of 8. In that case, I draw it from 3, 1 out of 8. So then I join the lines to get this histogram. So you can see that this side is number of heads, and this is the probability of the heads. See? So we have answered the question. First of all, we got the outcomes, and then we put them in the table by calculating the different probabilities to form the this table form the probability distribution. Then when we graph it, that's it. I'm sure you must be enjoying it by now. I told you. Okay, let's look at the next question. It says, during the summer months, a rental agency keep track of the number of chainsaws it rented each day during a period of 90 days. So the number of saws rented per day is represented by the variable X. You can see right here, number of chainsaws rented and the required probability, PX. No chainsaws were rested. Actually, this shouldn't be PX. This should be the frequency. Okay, let me fix it right away. This should be frequency. Okay. How many? No, how many? A number of days. This should be number of days. Number of days. Okay. Okay. Days. See. Okay. Let me save it. Okay, so that we don't have to do it again. All right. Number of days. Entered. So it says the number of days they didn't rent a saw is 45 days. They did not rent. They rented 1 saw in 30 days. Okay, 2 saws. Okay, that kind of thing. And then it says compute the PX for X. PS means the probability for all these values. Then construct a probability distribution and then graph the data. Okay. First of all, let's find compute the individual probabilities. The probability that they did not rent any saw at all is 45 out of 90 days. See? 45 out of 90, which is 0.5. That they rented one saw is 30 out of 90. How do I get 90? By adding all these days. Okay. Got 30 out of 90, give 0.33. You know, you can get it from the calculator. I always like to show it. Right, 45 over 90 give us 45 divided by 90. Give me right there. That's right there. 0.50. See? 0.5. That's what I got here. Same thing with the rest of them. So, like for example, this one 15 over 90. That is for the rented 2 chainsaws, 15 out of 90 days period. So you have can have it right here, 15, which is right here, 15 divided by 90. So 90 right here, 9 give me 0.166666. That's right here. But you round it up to 0.17. Okay? Good. So I have the required probability distribution right here. Now I can graph it. Look at the graph right here. For this first one is 0, is 0.5. So you gotta draw it from 0, draw it to 0.5. Say 0.5 right here, which is the PX. This is the number of chainsaws rented, which is our X. Okay? The next one is 1 is 0.33. 1, this is 0.3 right here. From 1 to 0.3. So 0.33, could be a little bit above it. See? So then 2.17 is 0.1 or 2.1 right here. So a little bit above it will give us 0.17. So this line, like I said before, I drew the line, then joined them at the top to get this histogram. So this is our graph. We answered our question. Having fun yet? Good. Next thing becomes, there are 2 requirements for us to call it a probability distribution. There are 2 requirements. First one is that the sum of all the probabilities in a sample space must be equal to 1. The sum of all the given probabilities must be equal to 1. If you look at the examples I've shown you before, you see the total is 1 if you add all these probabilities. The other one, if you add the this one is not a probability, so it won't give you it's a number of days, it's different. If you add this one, see, they give you 1 right here. Okay, see, 1. And this one as well give you 1 right here. So that is the first requirement. The second requirement is that the probability of each event in the sample space must be between or equal to 0 and 1, which means that the probability can never be negative, or that it can never be bigger than 1. See? So once it meets these 2 requirements, we call it a probability distribution. Otherwise, it is not. Let's see maybe 2 questions on that. It says, example 4, it says, would you consider this following distribution a probability distribution? You are given the distribution and you are given the probabilities. So all you have to do is to test it for the first requirement. Add all the probabilities to see if they are equal to 1. So that's what I did here. You add them here, get 1. So 1 over 5 plus 1 over 5 plus 1 over 5 plus 1 over 5 plus 1 over 5. So if you add all this, you get 5 over 5, which is 1. So the answer is yes, it is a probability distribution. Okay? So one more examples and we are done. Okay, it says, is this following a a probability distribution. Now, this one we don't even need to do anything because we can see that one of the probabilities is negative number. That is a no-no. It disqualifies it automatically. Not only that, there's one that is 1.5. The probability can never be 1.5. It can never be bigger than 1. If you have it here as one of the requirements, it can never be negative or bigger than 1. Okay? So that means it's not. This distribution is not a probability distribution. So, guys, I'm sure you enjoyed this lecture. I'm going to stop here today. Thank you for listening. In my next lecture, I will do more examples. I will show you how to calculate the mean and the standard deviation of a probability distribution, and then we go from there. Thank you once more, and please don't forget to subscribe to my channel so that you'll be informed when there's a new lecture available. Thank you. Bye-bye.